So we've learned a lot about the periodic table already. We've learned that just looking at the column number, those are called group numbers, you can tell that, for example, hydrogen's in column 1, group 1, that has 1 valence electron. Same with lithium, sodium, potassium. If we go over to group 15, for example, nitrogen has 5 valence electrons. Phosphorus, arsenic, same thing. We also know that the row numbers, those are called periods, that tells us how many shells there are of electrons. So potassium, for example, is in period 4, so it has 4 rings. And the outside ring, the valence shell, has 1 valence electron because potassium is in group 1. Okay. What we haven't talked about yet, and what this video is about, is that the periodic table is also organized into these areas by what type of element it is, right? Like all the elements in group 1, they all tend to behave the same way. They look pretty similar, they react really similarly, and that's all because chemistry happens because of valence electrons. So a bunch of elements with the same number of valence electrons, they're all going to be the same kind of elements as far as their properties are concerned. So because of that, these different areas of the periodic table have their own name, and so I'm just going to walk through the areas of the periodic table. You should memorize them. So on ptable.com, when we mouse over these areas, it highlights them, and the first thing we notice is that most of the periodic table is metals. Most elements in the universe are metals, shiny, bendy, right? Very few of them, just that upper right corner plus hydrogen, are not metals, and these are kind of the opposite properties of metals. They're not shiny, they don't bend, they tend to break. A lot of them are gases. Okay, so let's start with the metal neighborhoods. We've got group 1 is the alkali metals. Notice that hydrogen isn't in there because hydrogen is a gas, not a metal. And let's go ahead and make note of all these things here. So alkali metals, really interesting stuff. You can find all sorts of videos on YouTube about these. If you put a chunk of them in water, it'll either start the water on fire or explode. Super reactive metals. Okay. Next group, group 2, is called the alkaline earth metals. And let's just put this over here. Alkaline earth metals are also pretty reactive, but not as crazy as the alkali metals. One common example is magnesium. You can buy magnesium ribbon and you can light it on fire, so it's a metal that burns. In the middle of the periodic table here, we have the transition metals, and these are the metals that you are used to thinking about when you think about metal in general. Okay. We've got things like titanium, nickel. Nickels are made of nickel. Copper. Wire is made of copper. Zinc, silver, gold, iron. Okay, these are the metals we're most familiar with, and the reason we're used to encountering these is because we've gotten even less reactive still, right? We started in the alkali metals with super reactive metals, and now the transition metals are not very reactive. You can hold these in your hand and it's perfectly fine. Going further down that trend, this last corner before we switch over to nonmetals is called the post-transition metals, and these are the least reactive of the metals. These are very useful for when you don't want it to react. For example, pop cans are made of aluminum, because aluminum won't rust very easily at all. So it's a good choice. Now down here, these two rows, ptable.com calls them the lanthanoids and actinoids. Lanthanoids because the first one in that row is lanthanum, and actinoids because the first element in that row is actinium. Many other textbooks just lump these two together, and that's what I'm going to do today, and they call them the inner transition metals. And there's actually a secret kind of tricky reason why they're called that. on ptable.com, if we hit this wide button, you see that the real shape of the periodic table is much wider than you thought. And those inner transition metals are on the inside, right, between group 2 and the rest of the transition metals are those two rows. And the only reason that they're put on the bottom underneath the rest of the periodic table is because you can't fit this on a normal piece of paper, which is kind of goofy. So normally we see it looking like this, just so that it'll fit better on a piece of paper. Alright, so that's all of the metals. Okay, lots of the periodic table. In between the metals and nonmetals is this diagonal stair-step line called the metalloids, and these elements are really useful in electronics like phones, semiconductors, computers. Okay, they have some properties of metal and some properties of nonmetal at the same time. They're in between. So again, those are called the metalloids. We've got the main group of nonmetals right here. These are elements that you're very familiar with, like carbon, nitrogen, oxygen. Okay, just to the right side of those is group 17, which is called the halogens. That's a special chunk of nonmetals. ptable.com doesn't single them out with their own color, but most textbooks do give them a little extra attention. These are super reactive: fluorine, chlorine, bromine, iodine. Very, very reactive nonmetals. And then finally we've got the noble gases, and these are completely not reactive gases like helium, neon, and argon. And that's it.